Hi guys! In this video, we will discuss parallel and perpendicular lines. Let's start with parallel lines. Parallel lines are lines that will never intersect each other. Take for example these two lines over here with slopes m1 and m2. These two lines will never intersect because they are at the same perpendicular distance apart from each other. Even if we extend both lines on both sides infinitely, you can see to it that these lines will never intersect. And the condition for parallel lines is that their slopes are equal. M1 equals M2. If their slopes are equal, they are indeed parallel lines. On the other hand, we have what we call the perpendicular lines. Perpendicular lines are lines that intersect at a right angle, as shown by the little perpendicular symbol here, the little square. Now, the condition for perpendicular lines is that the product of the slopes m1 times m2 should be equal to -1. Or, if we divide both sides by m2, you will get this equation. m1 equals -1 over m2, or we can read this as the slopes of perpendicular lines are negative reciprocal of each other. Okay? Now let us use this concept to answer some example problems. Problem number 1. Determine if the lines are parallel, perpendicular, or neither. So, in this problem, we have two equations. 3x minus 5y equal 15 and 5x plus 3y equals 9. So to compare whether they are parallel, perpendicular, or neither, we must transform each of them into slope-intercept form. Let's start with the first equation. So, this 3x should be transposed to the other side and make it negative. Therefore, we have negative 5y equal negative 3x plus 15. And to isolate the variable y, we have to divide both sides by -5. Now, this simplifies to y equals -3 over -5, that's positive 3/5 x, and then 15 divided by -5 is -5, rather -3. Okay, according to slope-intercept form, just in case you don't remember, y equals mx plus b. The variable m, or the coefficient of x, is the slope. So in this case, the slope of this equation is 3 over 5. So let's write here m1 is equal to 3 over 5. Okay? Now let's proceed to the second equation. Let us solve for the variable y. First, let us transpose 5x to the other side and make it negative. So we have 3y equals -5x plus 9. And then let us divide both sides by 3. Therefore, this equation becomes y equals -5 over 3 x, and then 9 divided by 3 is 3 plus 3, wherein the slope is -5 over 3. So we can call m2, the slope of the second line, to be -5 over 3. Now let us compare. Is m1 equal m2? 3 over 5 is definitely not equal to -5 over 3. So it means these lines are not parallel. Well, are they perpendicular? Let's see. For perpendicular lines, the condition is that the product m1 times m2 should be equal to -1. Let us see. m1 is 3 over 5 times m2, -5 over 3 equals -1. 3 times -5 is -15. 5 times 3 is 15 equals -1. And -15 divided by 15 is -1. So -1 is indeed equal to -1. Therefore, we can say that these lines right here are perpendicular. Problem number 2. Same instruction. Determine if the lines are parallel, perpendicular, or neither? Our first equation, y equals 2x plus 1, is already in slope-intercept form. So, we can easily identify the slope, which is 2. Therefore, we can say that the slope of the first line, m1, is positive 2. Okay? However, for the second line, we must transform it into slope-intercept. So first, let us transpose negative 8x to the other side and make it positive. We have 4y equal 8x plus 12. Solve for y, so we have to divide both sides by 4. And therefore, this simplifies to y is equal to 8 divided by 4 is 2, and 12 divided by 4 is 3. And the slope is also positive 2. So this is AC. M2 is equal to positive 2, which means the slopes are equal. And since the slopes are equal, these lines are parallel lines. Next, determine if the lines, again, if parallel, perpendicular, or neither. So, both of these lines should be transformed into slope-intercept form. Let us begin with the first equation. Transpose 3x to the other side and make it negative. We have negative 4y equals negative 3x plus 4. And to solve for y, we have to divide both sides by negative 4. This becomes y is equal to positive 3/4 x minus 1. And we can say that the slope is 3/4. Okay? Let us write m1 is equal to 3/4. Next, the second equation, transpose 4x to the other side. We have negative 3y equals negative 4x minus 3. And then if we divide both sides by negative 3, this becomes y is equal to positive 4/3 x plus 1, wherein the slope is 4/3. So let us write here. M2 is 4/3. Are they parallel? So obviously M1 is not equal to M2. Okay? It means they are not parallel. Are they perpendicular? Let's see. Let's take the product M1 times M2. And if they are indeed perpendicular lines, this should equal to negative 1. Substitute. M1 is 3/4. M2 is 4/3 equal negative 1. 3 times 4 is 12, while 4 times 3 is 12. So we have 12/12 equals negative 1. And 12 divided by 12 is positive 1. And positive 1 is not equal to negative 1. So also, these lines are not perpendicular. You may get confused because they are reciprocal of each other. However, the condition for perpendicular lines, the slopes must be negative reciprocal of each other. Okay? So, since they are not parallel nor perpendicular, they are neither. And what does it mean? If they are not parallel and they are not perpendicular, it means these two lines intersect. Okay? Because they're not parallel, they should intersect. However, they intersect not at right angle. Okay? Like this angle theta right over here is not a right angle. Or either this alpha over that is not a right angle. So the answer is neither. Next, same instruction. Determine whether the lines are parallel, perpendicular, or neither. Let us transform each equation into slope-intercept form. if possible. For the first equation, all we have to do is transpose negative 10 to the other side. Therefore, we have y is equal to 10. Is that in slope-intercept form? Actually, no, because this is a vertical line. Recall that vertical lines have a form y equals c. Okay? Next, for x minus 10 equals 0, transpose negative 10 to the other side. Therefore, we have x is equal to 10. Now, this is a horizontal line. And horizontal lines have the form x is equal to c. And since one is vertical and the other is horizontal, like this, one is vertical and the other is horizontal, it means they are perpendicular.